Welcome back from an ad break. So now we're going to go back to our first concept, which is the formation of rust. Now remember that in this lesson we're looking at the rust formation and the prevention. So we're going to start with the formation of rust. How does it form, and also what is rust? So to define rust, we define rust as a slow chemical reaction of iron metal that is reacting with oxygen and moisture to form a complex compound. And part of that complex compound is iron oxide. So therefore, rust is a form of corrosion. We also need to know what corrosion is. And corrosion is the eating away and eventual destruction of metals by chemical reactions. The rusting of iron is the most common form of corrosion. So now let's break down the process of rust and see how it happens. So to begin with, we need to know and understand what rust is. Now that is a flaky, crusty, reddish brown product, and then we know that it forms on iron when that particular iron reacts with oxygen that is in the air. So this rust, it is a flaky, crusty, reddish brown product, and it forms on iron when iron reacts with oxygen in the air. Now, the oxygen molecules that we are finding in the air, they collide with the iron, with the iron atoms on the surface of the object. So that reaction is going to produce the iron oxide. So now how do we then write the chemical equation for this reaction? We say iron, so this is our weight equation, iron plus oxygen will react together to form iron oxide. So on this picture that we have here, we have our metal, our iron substance that is going to be colliding with the oxygen molecules from the air, and then when that collision happens, there's going to be a chemical reaction between the surface of the iron with the oxygen to form that reddish brown flaky substance, which is called our iron oxide. So then, now, the rusting process that you're talking about, it is very, very, very slow, and it's slow at room temperature. However, it happens much faster when it's near an ocean, for instance. So when that iron substance is near the ocean, that rusting process is going to occur faster. And why does it then occur faster near the ocean? That is because not only are there water droplets near the ocean, but then those droplets, they have salt in them. So the combination of the moisture, which is now coming from the water, and the salt in them, it makes the substance, or it makes the environment more corrosive. So that means the substance that is near the ocean is going to corrode faster, or is going to rust faster as compared to the substance that is inland. So when iron is exposed to oxygen in the air, a reaction occurs that we know that when iron is exposed to oxygen, and remember that oxygen is found in the air, and then there's going to be a chemical reaction. But then this chemical reaction happens slowly if it's not near the ocean. Now this iron is gradually eaten away as it reacts slowly with the oxygen. Remember, it reacts slowly, or the rust occurs slowly inland or away from the ocean. However, under wet conditions, the iron will rust more quickly. Now the wet conditions that you're talking about, that's now when the iron is near the ocean, because there's acid, there's salt, and then there's moisture. So that iron is going to rust faster. Now rust is a mixture of different oxides. However, we're going to be focusing on this one as it is an important one, whereby we're looking at the iron oxide plus the 3O2 reacting to form the 2FeO3, which is our iron oxide. Remember, the product formed from the iron and the oxygen is our iron oxide. So, other materials, we know that other materials can also weaken by the reaction with oxygen. So it's not only just the iron that can be weakened by the reaction between that particular substance and oxygen. Other materials as well can be weakened by the oxygen. And any weakening of a substance by oxygen is called a corrosion. So corrosion is the weakening by chemical reaction, and then that weakening, it is weakening a certain substance. Can either be an iron or any type of metal, right? Now, the rusting that you're talking about, it is a special form of corrosion that is involving iron. So the rusting involves iron, and then the other ones we can just refer to them as corrosion. So not all materials corrode at the same extent. So we know that rusting occurs in most metals, but then not all of them corrode to the same extent. For instance, the reactive metals, they corrode faster. Now, which reactive materials or which reactive metals are we referring to? We are referring to zinc, iron. Those two substances are going to corrode faster. Remember that the chemical symbol for zinc is Zn, capital letter Z and small letter n, and the chemical symbol for iron, it is capital letter F and small letter E. That's our iron. However, when we're looking at aluminum and chromium, those ones, they react slowly with oxygen, right? So the aluminum and the chromium, they're going to react slowly with oxygen, and when they do that, they're going to form a thin layer of either aluminum oxide or chromium oxide. So depending on what is reacting with oxygen, if aluminum is reacting with oxygen, there's going to be a thin layer being formed, and that thin layer, it is going to be called your aluminum oxide. But if chromium is reacting with oxygen, there's also going to be that thin layer, but that thin layer is going to be referred to as your chromium oxide. So aluminum has a chemical symbol capital letter A, small letter L, and then whereas chromium has a chemical symbol capital letter C and small letter R. So the aluminum oxide or the chromium oxide that we're referring to, it is a thin layer that is protecting the metal underneath. So when you're talking about aluminum, there's going to be a thin layer on top of aluminum being called aluminum oxide, protecting the aluminum. Whereas when referring to the chromium oxide, that's again another thin layer protecting the chromium, that is the metal underneath that particular metal oxide. Remember, metal oxide, that metal must be replaced by the specific metal that you're referring to. In this case, either aluminum or chromium. Then we end up with the oxide at the end. So we're just going to quickly take an ad break, and I'll see you just after this.